how do you go about calculating the number of unique groups when you don't care about order? When you start from the number of permutations? Does everybody understand the question? Okay, think about our tiny example here. We have AB here, and we also have BA here. So each group of 2 shows up how often? Twice. There are 6 permutations. Now, how many unique groups are there?
3.
3, which happens to be 6 divided by the number of times each group shows up. Yes?
How are there 3 unique groups?
I'm sorry?
Looks like there's 6 unique groups, not 3.
No. A, B, B, A. If you don't care about order, these are the same.
Okay.
By unique, I mean that you don't care about the order in this case. So if you don't care about the order and you have 4 people in the group, how many times, how can we start out with the number of permutations and find the number of what are called combinations, where each group is comprised of different individuals? What did we do here? 6 is the number of permutations.
So 4, 3, 2, 1.
So that would be 24 divided by 4?
Then you divide by the number of times the group shows up in the list, right? So in the list, if there were 4 people in the group, you'd be dividing by 24. If there were 3 people, you'd be dividing by 6. Each group of 3 would show up 6 times in the list. In this case, we have 6 permutations, right? Each group of 2, in this case A and B, each group of 2 shows up twice. So here we've got A and C, and here we got A and C, and here, and these are B and C, right? So each group of 2 shows up twice. And therefore, if you divide the total number of permutations by the number of times 2, in this case, each group shows up, then you get the number of unique groups. I see some nodding and some frowning, so.
When you go to the 4,
Yeah.
that's what gives me there. But if you're dealing with this, because we're not concerned about the third in this example. But if we were.
Well, we were though. Here we're saying how many ways can you organize 2 out of 3, right? I could do it, I suppose, with. Let's try it. If that will help. A, B, C, D. A, B, B, C. A, C, B, D, A, C, D, B, A, D,
I'll be here a while.
C, A, B, C, I've messed up. Yeah, you're right. I'm sorry. Yeah. Okay. And so, that's 6. And then we're going to get the same thing for B. B, A.
I don't think you have to write it all out.
Okay.
Out of the.
Well, the thing is, here, how many times are the first 3 going to show up? Well, you're going to find A, B, C here, and find it here, and you find it here. And in fact, you're going to find it enough places that it's 3 times 2 times 1, or 6 times. You're gonna find the same people, A, B, C, comprising the group, out of a total of, so, 4,
Oh,
no, not 24. No, you're right, sorry, 4 times 3 times 2, yeah, you're right, 24. So, how many different ways can you organize, individual groups?
If you don't care about order.
If you don't care about order. 11,
24 divided by 6.
24 divided by 6. And actually, there's a much easier way to see that. And you can think about it this way. How many ways can you leave out 1 from 4?
3.
No, there are really 4 ways. You can leave out each person once, right? How many ways can you leave out 1? Well, that's only 4. And there's perfect symmetry there. It's basically just a question of focusing on this side of the line rather than this side. Okay. It is a tricky thing, and we'll work on that a little bit more. But